Assalamualaikum. In this session, we will continue with the topics of gas chromatography. Let's understand the gas chromatography theory. Gas chromatography separation is based on the solubility and boiling point of organic liquids in order to separate them from a mixture. The basic principle of GC is based on solubility and boiling point. It is both a qualitative and quantitative like other chromatography. And for GC theory, as the gas moves, the gas is the mobile phase in the GC and the stationary phase is as usual, which is silica coated with a liquid. And as the gas moves, the solid means gas pass through our analyte through the stationary phase. The solid will be in equilibrium with the gas and the solid phase. Since there is a mobile phase, the separation will appear as chromatogram showing the separation of analyte. Let's understand the principle or mechanism of the GC. GC, the mobile phase is gas. When your analyte pass through the column here inside is the silica, outside is coated with the liquid. Some of the analyte tend to deposit on the liquid phase. Some tend to follow the gas. The ones that tend to follow the gas move with the gas will come out first and elute, and the one that is deposited on the liquid abundant in the liquid phase, it will come out later. This is the how the separation happens in the GC. The ones that come out first will have the lower retention time and follow the next compound and the last compound. This is how the separation will happen in the GC. All the flow is mobile phase is the gas. And this is the instrumentation part for GC, where like other IC and HPLC, we see the mobile phase here. For the GC, here is the carrier gas tank, because gas is the mobile phase for GC, and we go for the flow regulator to control how much gas we pass through the column. And in sample injection chamber, we inject our sample to pass through the column. Now mobile phase, which is gas, and sample will pass through the column, and with the different retention time, it will be detected by the detector. In GC, the detector will be the detector will be not the UV or ion suppressed like IC. It can be MS or FID, flame. Now go one by one. Before we go one by one, we should understand in details how's the flow of analyte inside the column. So as inert gas such as helium is our mobile phase, is passed through the column as a carrier gas, and it is the moving phase. A sample is injected into a pot which is more hotter than the column, and it vaporizes. As I mentioned previously, the things happen in the GC is based on the how it can be vaporized based on boiling point. So the lower the boiling point, it will come out faster, and the peak is have a shorter retention time, because our sample now it have to be heated by the oven in the GC, and now our sample must be in the form of vaporized and in the form of gas. So only gas can carry the gas. That's why our sample in liquid form need to vaporize by the high temperature, which is they have a oven inside the GC system, which is they need to vaporize a sample. So the gas sample mixed with the helium gas. Now sample turns into the gas form. Now it can be carried by the gas and begins to travel with the carrier gas through the column. Now the same phases, which is gas, now pass through the column. At the different compounds in the sample have different solubility and the column liquids, and these compounds cool albeit they are deposited on the column support. If they pass through the column, they have a cool a little bit, it will be deposited on the liquid phase coated inside the column, and the one that have still in the vaporized form, it will pass elute out, and they have a shorter retention time. However, the column is still hot enough to vaporize the compounds, and we do so by a different rate since they have different boiling point. That's why separation or elution order for the GC is most on the boiling point of the compounds. After we understand the principle of GC, which is separation based on boiling point and the volatility, now we go for the instrumentation part for GC. The first part is the carrier gas, which is the mobile phase. Must be chemically inert, such as helium, nitrogen and hydrogen, and it must be associated with the pressure regulator, gauge and flow meter to control how much gas will be flowed through the inside the system. Next will be the sample injection system. The most common method for sample injection system involve the micro shrink to inject a liquid or the gas sample. So our sample injection system can be split or splitless injector. Splitless mean all your sample will be injected directly to the column. If split, only a few will be heat up as a vapor and pass through the column, and others will be passed through the waste. So split and splitless injector, as I mentioned just now, some sample vaporize to form a mixture of carrier, and a proportion of the mixture pass into the column, but most exit through a split outlet. If you split the sample, it will be some only will be vaporized and some will be go to the waste. And if splitless, all the sample will be vaporized and pass through the column. That's the function for the injection of split and splitless injector. Now next part is column. Column have encountered in GC have two types, which is packed and open tubular, or known as a capillary. The column length is quite different with the HPLC, which is 150 meter only. For this one is for 2 meter, for HPLC 150 centimeter. So this one is like 2 meter and 50 meter, or it become more longer, and it is formed in this coil, formed in this type of form. So it become longer, and this is the type of the column. And this is the packed column, where all the silica just packed inside this tubing. And for the capillary, they have a supporting material around the wall of the column. Liquid phases coated around the column and coated with a polyimide layer. This is for capillary. Temperature can support 350, and internal diameter 0.1 to 0.75, and film thickness is 0.1 to 5 micron, and column length quite long because in the form of this one compared to the HPLC only centimeter. So as ID and film thickness increase, sample capacity increase, but efficiency will decrease. This is the size. They always written down for the labeling of this column. So what is the difference between packed and open tubular or capillary column? The most common use is the capillary column. Inside the schematic of the packed column is like this. The internal diameter is quite big, 4 millimeter internal diameter, and for the capillary is quite small, 0.2. And this one outside will be coated by polyimide coating material, and inside is the fused silica. For the pack, they pack with all the silica material inside. That's the difference. So type of open tubular have a different type. Liquid phase Stationary liquid phases, they have a coated with liquid phases. Solid coated also have, and stationary solid phase particular also have. This one is known as wall coated open tabular column. This one support coated if solid coated with stationary liquid phase, and this one is for porous layer open tabular column. This is for the capillary column. They have a different type. So the two different types. Comparison. Wall coated consists of capillary tube whose wall are coated with a liquid stationary phase. For supported coated, it have a capillary thin layer of material such as diatomaceous earth, and this is the difference between these two columns. So Scott is less efficient than WCO column. So both type are capillary column are more efficient than packed column. And column bonded phase are prepared by reacting a desire like a silica surface and cross-link over the phase covalently attached stationary phase. We change the properties of column. When we change the R value covalently attached to the silica stationary phase, we have a different properties. This is a different properties, different type of column in GC. The common we use in our lab is DB wax. The property of column is polar column. So means the 10 we need to separate for this type of column is the non-polar compounds. If we use DB5 or HP5, this is the low polarity of the column, so it's suitable for separation of polar compounds. This is the structure, what inside percentage about R group inside the GC column. And column, as I mentioned just now, the main compartment in GC should have a column oven. Why? We need to vaporize all the samples or analyte in form to change our analyte from liquid to gases. So that's why the temperature must depends on the boiling point of our sample. So the temperature equally slightly above the average boiling point of sample result in reasonable elution time. So detector, as I mentioned just now, the detector must detect our sample with the range of temperature at least 400 degrees and good stability and reproduce, adequate sensitivity and have a linear response to the solute. And the detectors commonly used is FID, flame ionization detector, the most widely used detector in GC. This is based on the production of ion when compounds are burned. So our compounds in gas, when it overburn, it will change into the ion. It will be detected by the FID. That's how the principle of detector in GC. The TCD is operates the changes in the thermal conductivity of the gas stream brought about the presence of analyte molecules. And another detector can be used in GC rather than FID and TCD. It can be used ECD, FDD, PID or mass spectrometry. That's all for compartment for GC. Thank you.